So this is the last topic in your chapter. So we are going to learn how to solve the first order PDE using Laplace. So for example, you have your equation u in the terms of x and t. So what you're going to do, you're going to assume Laplace of u of x and t as capital U, x and s, where capital U is a function of x and s. So now let's take this. So Laplace of del u by del t is given as 0 to infinity e raised to minus st del u by del t. This was the first formula we learned when we did Laplace. So now if I apply integration by parts, I'll get e raised to minus st integral 0 to infinity del u by del t dt minus integral 0 to infinity minus s e raised to minus st integral del u by del t dt and dt. So you'll get e raised to minus st u of xt 0 to infinity plus s 0 to infinity e raised to minus st u of xt dt. So you will get 0 minus u of x and 0 plus s times u of xs. So this is your Laplace of del u by del t, which I will write as Laplace of u dash. It is s multiplied by u of xs minus u of x comma 0. So you do not need to remember all of this, just remember this formula. Similarly, if I want to find L del u by del x, it is 0 to infinity e raised to minus st del u by del x dt. So this is del u by del x will take outside, 0 to infinity e raised to minus st u x comma t dt. So the answer is d by dx u of x comma s. We can replace del by d over here. So let's take an example. Again, guys, you do not need to remember this working. Just remember these two formulas, 1 and 2. So let's take an example. Ux plus x ut is equal to 0, where u of x comma 0 is 0 and u of 0 comma t is t. So ux means del u by del x and ut means del u by del t. So let's write Laplace of u of xt is equal to u of xs. Laplace of ut is s u xs minus u x comma 0, which is given as 0. So this becomes s u x comma s. And L of ux is d by dx u of x comma s. Now let's replace it in the original equation. So let's take Laplace on both sides. Laplace of ux plus x ut is equal to Laplace of 0. So this becomes d by dx u of x comma s plus x s u of x comma s is equal to 0. So now let's solve this. We have du by dx is equal to minus xsu. I have written u of xs as simply capital U. So if I rearrange this, I can write this as du by u is equal to minus xs dx. So now let's take integral on both sides. So here you get ln u is equal to minus s x square by 2 plus ln c. See, here you can write simply c as well, but ln c will make things easier for us. So we're going to use ln c. So this is ln u minus ln c is equal to minus sx square by 2. So you can write this as ln u divided by c is equal to minus sx square by 2. So u by c becomes e raised to minus sx square by 2. So u becomes c e minus sx square by 2. Now you are given an initial condition in the question. U of 0 comma t is t. So let's use that. U of 0 comma t is t. So Laplace of u of 0 comma t is Laplace of t. So u of 0 comma s, capital U, is equal to 1 upon s square. That is Laplace of t. So if I write this as equation 1 and this is equation 2, I can say that 1 upon s square is equal to c e raised to 0, because this is when we have written x as 0. This was the value of x. So when x is 0, you can write it like this. So you got c as 1 upon s square. Basically, you cannot leave the answer in c if you have an initial condition given to you. So now let's go back here and plug that in. So you got u as one upon s square e raised to minus sx square by 2. So this is Laplace of u of x comma t. So you'll get u by taking Laplace inverse of e raised to minus sx square by 2 divided by s square. So let's focus on this. So Laplace inverse of 1 upon s square is t. So let's say this is ft. So your u becomes f of t minus x square by 2 into, now actually we need to write unit step function over here, but since we already have u, I'm going to write it as h. But remember, h is just the unit step function that we did previously. H t minus x square by 2. So as this is ft is t, so you just need to replace t by t, which means there will be no changes. So you will get u is equal to t minus x square by 2 multiplied by h into t minus x square by 2. This is your answer. So this was the last topic in this chapter. If you guys have any doubts, leave them in the comment section or DM me on Instagram. I will make sure I answer. Thank you.